One of the most requested topics in recent weeks has been the BLC1 radio signal. The story suddenly resurfaced after lying dormant for years, fueled by rumors that it was still being discussed within SETI circles as a potential candidate for an alien signal. However, this notion is very much incorrect. It either stems from a significant misunderstanding of what actually happened with that signal or is the result of a borderline hoax, propagated by certain unscrupulous media outlets and subsequently blown out of proportion. To be clear, BLC1 is no longer considered a candidate for an alien signal. It is now overwhelmingly thought to have been caused by Earth-based interference, making it an initially intriguing candidate in SETI's history, but one that eventually led to a more mundane explanation. There is a lot of misinformation circulating about this signal, which is why it's crucial to address the confusion and set the record straight. BLC1 stands for Breakthrough Listen Candidate 1, and was the first significant candidate signal detected by the privately funded Breakthrough Listen project, a SETI experiment. The signal was identified and recorded in April and May of 2019 for a total of 30 hours, and its announcement came on December 18, 2020. However, the main issue with the recent attention is that this is an old detection, not a new one. Despite being detected years ago, it recently gained renewed interest due to its origin appearing to come from the direction of Proxima Centauri, the closest star to our solar system. This was problematic from the start because it is incredibly unlikely that the first potential alien signal would come from our next-door neighbor, Proxima Centauri. The odds of two civilizations reaching similar technological states and coexisting with radio communication capabilities at the same time in neighboring star systems are extremely slim. If this were indeed the case, it would imply that the galaxy is teeming with alien civilizations, and we should see evidence of them everywhere we look, but we do not. This is why it's called the Great Silence, due to the profound lack of any confirmed alien signals so far, despite extensive searches. If there were a galaxy-spanning civilization colonizing every usable star system, we would likely see signals from multiple nearby stars, not just one. In that scenario, most stars should show signs of being colonized, yet we do not observe this. However, it would be quite unnerving if all the stars around us appeared to be colonized, except our own. This would hint at something like the zoo hypothesis, which suggests that an advanced civilization might deliberately leave certain star systems untouched. While we don't see aliens everywhere, it is conceivable that somewhere far away, a civilization could be stuck in such a scenario. If this were true, it would indicate that the galaxy is already under the control of a superior civilization that enforces isolation on the lesser one, preventing them from colonizing other stars. The BLC1 signal was initially detected at a frequency of 982.002 MHz, which presents another issue. In radio astronomy, there are specific frequencies, such as the famous 1420 MHz associated with the WOW signal, that are expected to remain silent for observational purposes. These quiet regions are essential for studying the hydrogen clouds of the Milky Way, as neutral hydrogen emits radio waves within these ranges. However, the frequency of 982 MHz is notoriously problematic, as it falls within the UHF range, which is heavily occupied by radar, television, mobile phones, wireless networks, and countless other sources. This makes distinguishing between a genuine extraterrestrial signal and Earth-based interference particularly challenging. Interference is a common issue in radio astronomy, where filtering techniques are often used to remove it. However, these methods aren't always effective, as was the case with BLC1. The study was scanning around 800 million channels simultaneously, ranging from 700 MHz to 4 GHz, which coincidentally overlaps with the frequencies used by microwave ovens. This brings to mind the famous story of the Parkes Radio Observatory picking up interference from their breakroom microwave oven in 1998. The scientists didn't suspect alien activity. Instead, they were aware that the signals were likely terrestrial in origin, although they initially considered the possibility of lightning. Interestingly, BLC1 was also detected by the Parkes telescope, which had a wide beam pointed roughly at Proxima Centauri. However, the signal could have originated from anywhere within a 16 arc-minute circle in space, raising the possibility of a distant source. The signal exhibited a notable Doppler shift in its frequency profile, but in the opposite direction of what would be expected from Earth's motion. Instead of decreasing in frequency, it increased, which contradicted what would be expected from an alien signal in this context. Moreover, after the initial 30-hour observation window in 2019, BLC1 was never observed again, placing it in a similar category as the WOW signal, which also did not repeat and couldn't be confirmed. To confirm a signal like BLC1, multiple observations are needed, ideally with several telescopes verifying the findings to rule out receiver noise. BLC1 didn't pass this test, indicating that it was never a strong candidate for a SETI signal but rather a spurious signal of interest, even less compelling than the WOW signal. SETI scientists employ a standard procedure where they move the telescope on and off target to verify if the signal persists when off target. This helps eliminate glitches or some types of interference. Although Parkes is isolated from radio interference as much as possible, it still picks up significant amounts of it. BLC1 did pass this particular filter, which is why it initially attracted attention. Another complication arose around the same time BLC1 was making news in 2020. An unrelated study reported a bright, long-duration optical flare coinciding with radio bursts from Proxima Centauri, based on completely separate observations conducted simultaneously with the BLC1 detection. Had BLC1 withstood scrutiny, this flare would have complicated the interpretation of the signal, potentially indicating a previously unknown way for the star to emit a narrowband signal. However, the existence of this flare raised further doubts about the habitability of planets around Proxima Centauri, as such flares would likely strip any atmosphere away from these planets over time. The final blow for BLC1 as an interesting signal came in late 2021 when two papers questioned its validity. One study reanalyzed the entire dataset and discovered numerous other signals similar to BLC1, none of which passed the telescope wagging filter. These findings, combined with the other similar signals, led researchers to conclude that BLC1 was not a unique or extraterrestrial signal, but likely just another case of radio interference or noise. It seemed like the signals were originating from oscillators in electronic devices, indicating human interference. In other words, it simply mimicked what might loosely be expected from a legitimate SETI candidate, close enough to pass the computer filtering designed to eliminate most interference. However, it must be noted that the specific source for BLC1 has never been identified, but this is true for the vast majority of mistaken signals detected by SETI. There are numerous human radio sources, some of which are secret spy satellites transmitting on unknown frequencies. At this point, the chances of BLC1 being an alien signal are very slim, and it was almost certainly just interference. Regardless, any strong SETI candidate must be unambiguous, which BLC1 never was. This situation raises an interesting idea. We generally assume that alien radio signals would either be straightforward, like someone's radar, or signals intended to be intercepted as contact messages, and thus as clear as the aliens could make them. But there's another possibility: decoy signals and deception by an alien civilization. For instance, if an alien civilization wanted to hide its homeworld, it might remain radio quiet but set up a massive transmitter in a nearby star system to create the illusion that it's their native star. This strategy could mislead observers into focusing on the wrong location. In the distant future, humans could find themselves heading towards the stars, lured by a tempting signal, only to discover it was a trap. Something lurking within that system could be waiting to eliminate any industrious civilization exploring space to keep the real homeworld concealed. Thank you for watching. Subscribe to my channels for regular, in-depth explorations into the interesting, weird, and unknown aspects of our amazing universe.